Hello, my name is Naseem, and in this video I am going to talk about the binomial distribution. Before jumping into the binomial distribution directly, I want you guys to walk through into some of the prerequisite, fundamental knowledge we must have prior to going into this binomial distribution. There are number of experiment and outcome of those experiment are in the form of directly success or failure. So what I mean by saying this, for example, we have a coin, pair coin, we have head and tail on the surface of this coin, and if we are considering that appearance of head as a success and the appearance of tail as a failure, the outcome of this experiment would be in the two form only. I mean binomial form only. It have only yes means success, or it have only no means not success. If we are getting head, we are considering it as a success, and if we are getting tail, we are considering it as a failure. And this type of experiment, we call them by outcome experiment. When we are doing number of trials of this experiment of success and failure, and when we are collecting all of this data into the form of sample space, and when we are trying to find out probability, we will get this probability in the form of we can make a formula out of those collection of success and failure, and that formula we call it binomial distribution. One more thing I want to talk about here is that this binomial distribution is a discrete distribution. So let's start with the fundamental knowledge of binomial distribution. So for example, we have a coin. Let's try to understand binomial distribution fundamental by the use of a experiment. So again, we have a coin, a fair coin. We have head and we have tail. Head we are saying success, and tail we are saying failure. Now we are doing an experiment. We are tossing this coin continuously 3 times, and we are collecting the sample space of this experiment. So the total number of outcome of this experiment means tossing a coin 3 times in a continuous manner, and we wanted to find out all of the possible outcome of this experiment. So what we would have, this would be the outcome of this random experiment we are doing. And when we are saying the head is a success means S, and tail is a failure, and if we have a random variable, and random variable we are saying the number of success, right? So we have a random variable X, number of success. Number of success, I mean number of heads appear in the outcome of the random experiment which we are doing, right? So the maximum number of heads means success would be 3, means all 3 times we are tossing coin and we are getting head. The maximum number of means success would be 3. Then we can get 2, which is HH means 2 heads in any manner. We can have 1 head means 1 success, so 1 head at any time. We have 3 heads means this 1 head in these 3 outcomes. We may get no success means all of the 3 times we are tossing coin we are getting only tail, we are not getting heads. So this is the outcome. So these are all of the possible values we are having of this random variable which we have, number of success. And if we are saying that getting success, the probability of getting success is equals to P, for example, and probability of getting failure is equals to 1 minus P, because if probability is 1 and we have an event, its probability is P, then the other failure probability will be 1 minus P. So we are considering 1 minus P as a Q, right? So we have success probability P and we have failure probability Q. Now try to find out the probability distribution of this random variable, means number of success. So we have P means probability of X when it is getting 0 value, this one. And we are getting X equals to 0. What is the outcome? So we have outcome favorable to this specific condition, which is tail on 3 times. We are not getting any success, means we are not getting any head. We wanted to find out probability of tail. How to get probability of tail? So because this tail is itself a failure, right? And we have probability of failure as a Q, right? So as a result, we need to find out probability of T means probability of failure, probability of T multiply probability of T. And because failure probability we have Q, so we will get Q raised to the power 3. So this is the probability of getting no success in this experiment. This would be the probability of getting no success in this specific experiment, right? Now let's try to find out probability of getting 1 success, means we are throwing coin 3 times and we are getting head at least 1 time. The favorable outcomes of this specific condition, getting 1 success, at least 1 success means getting at least 1 head. So we have 3 outcomes favorable to this. We have H at least 1 time, H at least one time and H at least one time in these three, outcomes. So let's write down them here. We have T, H, T. We have H, T, T. We have T, T, H. These are the outcomes which are favorable to this specific condition, means getting at least one success, getting at least one head. Now try to find out probability. So we will get probability by this specific condition THT plus probability of HTT plus probability of TTH, right? And if we open it, what we will find out, probability of T means probability of failure, probability of success, probability of T. So we are doing right, and the same time we will get probability of H means success, probability of failure, and we will get probability of failure multiply probability of failure multiply probability of success. All right, and PT we have Q, so just write down the values PT, PQ multiply P, because probability of success PH we have already defined P, right? And probability of failure we have this one. Again we have PH P, we have PT which is Q, we have again PT which is plus, we have PT once again, so we write Q, PT once again Q, and we have PH which is P. All right, so we have 3PQ square, because in each of the parameter we have 2 times Q and 1 time P, so we are adding them, and as a result we find it. Same, if we find out probability of X equals to 2, means at least we are throwing coins 3 times and at least 2 times we are getting heads, means success 2 times in this experiment. Probability of this experiment in the same manner, what we will find out is that as a final output it will be again 3p square. Now X equals to 3 means all the 3 times we are tossing coin we are getting head, and the favorable outcome for this is this one only, heads on all of the 3 times, and the probability of this would be p raised to the power 3. If we create the probability distribution list, what we will find out is that we have 0, 1, 2, 3, and the probability for 0 we have q raised to the power 3, this one. We have for X equals to 1 3pq square. We have for 2 we have 3p square q, write down, and we have p raised to the power 3 for X value 3, right? This is the probability distribution of this random experiment of getting success at the different times starting from 0 to 3 in this specific experiment. So what we are finding out is that we have coin and we are throwing this coin 3 times. We have 3, and if we have probability of getting success as P and probability of getting failure as Q, and when we are doing this experiment for 3 times, so the probability distribution would be same as we are doing P plus Q raised to the power number of times we are doing experiment. If we open this equation, what we will find out is that P raised to the power 3 plus Q raised to the power 3 plus 3p Q square plus 3q P square. This would be the formula for this specific equation, and the same we are getting here. P3 we are having here, Q3 we are having here, 3p square we are having here, 3pq square. So this actually random experiment and its outcome in the form of probability of failure and success is following a specific formula. So if we are having a experiment, the probabilities of of 0, 1, 2, 3, the same time n number of success can be obtained by using as first, second, and n plus 1 term in the expansion of p plus q raised to the power n equation. If we wanted to find out probability of 0, 1, 2, 3 or n number of success in an experiment, and we are having first, second, and n plus 1, then p plus q raised to the power n would tell us the probability. So let's try to understand the binomial theorem in a standard formula, right? So we have done an experiment and we wanted to find out probability of x number of success in an experiment, and we have done this experiment n time. All right, so we wanted to find out probability of x, of a specific x, means discrete x, we wanted to find out. Current formula for binomial distribution would be n factorial, means times we have done the experiment, right, divided by x factorial, means the specific number we wanted to find out the probability of, multiply by n minus x factorial, multiply by p raised to the power x, multiply by q raised to the power n minus x, where p and q probability of specific success, all right, and q is the probability of failure. All right, so this specific formula we have is called binomial distribution, right? We can use this formula to find out probability of any specific number in an experiment done. But binomial distribution have some some conditions to apply, and there are a number of conditions to take care while applying this binomial distribution on the experiment which we have, right? And what are the conditions? The first condition is that the number of outcomes should be finite. As in this experiment we have done, the number of outcome of this experiment was 8 only. We have total number of outcome 8. All right, we have n equals to 8. Second condition is that these getting failure and success while throwing a coin, means tossing a coin, we are getting head means success, we are getting tail means failure. This probability of success and failure in this specific example we have 0.5, we have 0.5 when we are saying this coin is a fair coin. So the getting 0.5 and 0.5, we have a specific condition, we have a specific probability of getting success and getting failure. This probability should be independent, means the occurrence of tail should not change the probability of getting head at any point of time. Means the outcomes of the experiment must have independent in each other. I already talked about dependent and independent events of a random experiment. You can see this video if you want to gain more knowledge about dependent and independent outcomes, right? So the second condition, these events, means this getting failure and success, must be independent. All right. Third condition is that each event of the experiment, as we have here, each event of the experiment must have only two outcomes. It should have only success, it should have only failure. So in this example we have done, we are considering head as a success and we are considering tail as a failure. So these are the only two possible outcome of a single experiment of tossing one coin. So the third condition is that the experiment must have only two outcomes, and these must be success or failure, right? This is the third condition. The very fourth condition is that the probability of getting success must be remain constant in each experiment, in each outcome. So what I mean to say by this, when we are tossing a coin, the probability of getting head is 0.5. If we are tossing coin first time, the probability is 0.5. Then if we are tossing same coin second time, the probability of getting success should not be changed. Let me try to understand this specific condition by by doing another experiment. So we have a bag, and in this bag we have 10 different balls. So 6 ball we have red and 4 ball we have yellow, right? Now we are doing an experiment where we are interested in finding out the probability of getting yellow ball. So we have total 10 number of balls, 6 balls are red color and 4 balls are yellow color, and we are saying drawing yellow color is a success, yellow color is a success, and drawing red ball is a failure. All right, so what is the probability of getting yellow ball from this bag? So probability of yellow, we will have 4 by 10. All right, this is the probability of getting success, means yellow ball. We are getting out one ball from the experiment, and we are interested in finding out the success of the experiment, means getting yellow ball, and we are not giving back this ball back to the bag. So first time if we are getting out one ball from the bag, we will remain only 9 ball. All right, so the probability of next ball would be somewhere, if yellow ball is already out, would be 3 by 10. All right, so the probability of success is changing in the experiment. But the fourth condition of binomial theorem is saying that the probability of success should not be changed. It should be remain constant throughout the experiment. So this formula will tell us the probability of the things, probability of discrete success. To clarify your understanding with the video material, I have pasted a link into the video description. Just go there and read the material. It would be more helpful to you. Thank you for watching this video. Happy learning and see you in next video.